And now let's continue our journey to the center of the earth. We're going to go into the core. All right. You'll notice in the picture that there's actually two parts to the core, the outer core and the inner core. And just like we talked about the moho as kind of a boundary between the crust and the mantle, within the core, there's a couple other boundaries called discontinuities that have been given names. One's the Gutenberg discontinuity, and then you have the Lehmann continuity. And in 1914, there was a German geologist, this guy Benno Gutenberg. He was analyzing those seismic waves and concluded that there must be another drastic change in the makeup of the Earth significantly below the moho. And that boundary marking that change is now known as the Gutenberg discontinuity. And that is basically marks the beginning of the Earth's core. And what's fascinating is the core is remarkably different from the mantle. Now, it's mostly made up of iron, not silica, and there's a small amount of nickel in the core, along with at least one other element. And below the Gutenberg discontinuity, the core is actually liquid, not solid. And when I say liquid, I mean we're talking liquid, right? Okay? It's liquid because at that depth, okay, the temperature is hot enough to melt iron and the other constituents in the outer core. Now, what's interesting is in 1936, there was a Danish scientist, Inge Lehmann, who did work with seismic waves that led her to realize that the core actually has an inner region that is solid. And this leads us to two separate parts to the core, the inner core and the outer core. And the boundary between these two regions, guess what, is named for Lehmann. It's called the Lehmann discontinuity. The outer core lies just below the Gutenberg discontinuity and is mostly molten iron. And then the inner core lies below the Lehmann discontinuity and is mostly solid iron. Now, the exact distance from the surface of the Earth to the Lehmann discontinuity is not really well known, or it wasn't known until about 1960. At that time, when they were doing underground nuclear tests, the resulting seismic waves, okay, actually gave us an interesting indirect observation of the Earth and shared some interesting facts about the Earth's core that we learned, and not just the core but the mantle as well. And the precise position of the Lehmann discontinuity was learned from that. So we've got the outer core that's liquid, and we got the inner core that is solid. Whoa, what's going on? Well, as you read in your textbook, it's this thing called pressure freezing. Basically, there is so much pressure that it turns liquids into solids. Yeah. Alrighty. If you would, got a couple questions to check your understanding, and then come on back and we'll continue with the lecture.